Let's talk for just a few minutes about dividing complex numbers. So when we're dividing in math, it's not proper to leave a radical, I, or a negative in our denominator. So let's just look at a few examples of what if we end up having to divide by something with I or a complex number at the bottom. So the first three examples I have are just if you're dividing by a monomial, just one term that has I in it, what do you do to get rid of it? So 2 divided by 3i is our first example. So to get rid of I, we know that I squared equals -1, so we can use that to help us clean these up really easily. So if I multiply the denominator by I, it's going to make that into 3i squared, which is going to turn into -3. So I also multiply the top, because remember with fractions, if you multiply by I divided by I, it's really like you multiply by 1, so that's still why that is okay. So let's write out the numerator would now be 2i divided by 3i squared, and then I squared can be replaced with -1, and so we would have -2i over 3 left over, because we can just write the negative in our numerator, which gets it out from the denominator. So our final simplified form of number 1 was -2i divided by 3. So let's look at number 2. This one has 2i, and again, I can use the fact that I squared equals -1 to help clean this up. And so let's just multiply the top and the bottom by I. But this time in my numerator, I have a binomial, so I need to distribute the I. And that will become I plus 4i squared over 2i squared. And that will become, each of those will become a -1. So where I had I squared will now equal -1 because I can replace it with -1. So it'll be I minus 4 in the numerator divided by -2 in the denominator. And like I said, we don't like to leave a negative in the denominator, so you take it and distribute it to the numerator and rewrite it. So we have -I plus 4 divided by 2 would be a better answer for our simplified form for number 2. Let's look at number 3. We have 4i, so you probably noticed what's happening here. Each time we have a monomial, we just need to multiply the top and bottom by I. So let's do one more like that, and then we'll look at some that are a little different. So in my numerator, I can distribute the I, so I would end up with 2i plus 3i squared divided by 4i squared, because those multiply to be 4i squared. I replace I squared with -1. So now I have 2i plus -3, so that's 2i minus 3 divided by -4. So again, let's just write it so the negative is in the numerator. So distribute the negative to the top, and that just makes it more proper. So that is our simplified form for number 3. Now, we're going to look at dividing by a binomial. Those work a little differently and require a little more work. So first thing we need to look at is what the word conjugate means. A conjugate is when you take a binomial and you just change the sign in the middle. So for example, if I have 2 plus 3i, the conjugate of that is 2 minus 3i. If I have -4 minus 5i, the conjugate of that is -4 plus 5i. So notice only the sign in the middle is changing for your conjugate. So in order to divide by a binomial that's in the form a plus bi, it's a complex number, we need to multiply the numerator and the denominator by the conjugate of the denominator, because the denominator is what we're focusing on cleaning up on these examples. So for example, we can call this example 4. We're going to multiply by the conjugate of 2 minus I, and we need to multiply the top and the bottom. So the conjugate of 2 minus I is 2 plus I. So I multiply the top and the bottom by 2 plus I. Now let's see what that is. So 4 would distribute to the 2 plus I. So I get 8 plus 4i. And then in the bottom, it's a difference of squares. So you could FOIL it, or you could think about difference of squares and how that works. The middle terms always cancel out. So I would end up with 4, and then 2i and -2i would cancel out for the inside and the outside terms. And the last term would be negative I squared. So then I squared is negative 1. So I'm going to simplify a little further and get 8 plus 4i. And then 4 minus negative 1 would just be 5. So that's considered more simplified and proper because I don't have a complex number in the denominator anymore. So I'm done with that one, and I can't divide anything else. Let's do one more of those. So we want to multiply by the conjugate of the denominator because the denominator is the part of this that's not proper. We got to clean it up. So the conjugate is 2 minus 3i. You multiply the top and the bottom because remember it's like you're multiplying by 1, which is why this is okay. So in the numerator we need to FOIL, and in the denominator it's like a difference of squares. So you can FOIL, or you can think of how difference of squares works out to be a little shorter. So let's go ahead and do the denominator, speaking of that. So 2 times 2 is going to be 4. The outside would be negative 6i, and the inside is 6i. So they cancel out, which always happens with difference of squares when you're putting them back together again. And then the last 2 terms would be negative 9i squared. Let me write that first before I replace it. Okay, so then in the numerator, we do need a FOIL because these are not a difference of squares. So first times first would be 8. Outside times outside is negative 12i. Inside times inside is 10i, and last times last is negative 15i squared. So now we just need to keep simplifying. So I squared is negative 1. We can say 8, and this will become positive 15. So 8 plus 15 is 23, and then negative 12i plus 10i is negative 2i, divided by 4, and this would become positive 9, so 4 plus 9 is 13. So we have 23 minus 2i over 13 for the simplified form of our original example. So the goal here was to clean up the denominator and not have an imaginary number as part of our denominator.